All right, fellow coders, let's talk Hugging Face. It's like this giant library, right?
It is.
Open source,
Mhm.
full of pre-trained machine learning models, and you can just plug them right into your projects. Like if you need something, chances are you don't have to build it from scratch.
Yeah. Someone's already done the hard work
Someone's already done the heavy
of
lifting.
made it available.
Yeah, and this is where GitHub comes in because it's full of Hugging Face repositories,
Hmm.
but they're not all the same, are they?
No.
No. So today on this deep dive, let's figure out how we as developers can navigate this whole thing, grab the right files, understand what we're even looking at.
Yeah, it's like you're walking into a hardware store, right? You've got to know which tools you need for the job. You don't want to end up with a screwdriver when you really need a hammer.
Okay, so perfect analogy. So let's say I need a model that can summarize articles. Where do I even begin?
Hugging Face has this amazing website with a model hub. It's got a really good search. Just type in text summarization, and you'll see a ton of options.
I'm looking at this list of models. How do I pick the right one? They all kind of sound the same.
You have to look closer. Each model has a model card. It's basically like a product description.
Okay.
It tells you what the model's good at, how it was trained, how it performs.
So I should be looking for, if it's been trained on summarization specifically.
Yes, definitely the task.
Okay.
And then you want to look at things like the size of the model.
Okay.
Smaller model might be faster, but potentially less accurate. Larger model could be more resource intensive. It comes down to your needs.
Yeah. Resources, especially for indie devs or people working on personal projects. I've noticed some models have all these different files. They don't always make sense. What should I be looking for?
You'll see a lot of different file formats like .bin, .safetensors, and .guf. They're just different ways of packaging the model data that's optimized for a tool called Kobold CPP. It lets you run these models locally, so you don't have to rely on cloud services.
Okay, interesting. Now, what about these Q numbers I see? Q4KM, Q5KOM. It looks like some kind of secret code.
That's quantization. Basically, it refers to how much the model's data has been compressed. This affects its size, its speed, and to some degree, its accuracy.
So a higher Q number means more compression.
Yeah.
A smaller file, but maybe a little bit less quality.
Exactly. It's a trade-off. The model card usually will explain these nuances. Sometimes it'll even have a comparison table. You can see the differences between the levels.
Okay, so I've picked my model. I get the file formats. I understand the Q numbers.
Yeah.
How do I actually get these files from Hugging Face onto my computer?
Well, there's a few different ways. Depends on what you're comfortable with, I guess.
Hit me. Command line, GUI.
Okay, well, let's start with the simplest. The Hugging Face CLI.
Okay.
It's a command line tool. It was designed specifically for interacting with Hugging Face. You can install it, just a simple pip install command.
All right, so for people comfortable with the terminal, that's the way to go. But what about those of us who prefer a little bit more of a visual approach?
Well, if you're on the Hugging Face website, looking at a model, you'll see a download button. Usually that downloads the whole repository, which can be a little bit much.
Sometimes you just want everything, but yeah, I get it. What if I only want specific files from a repository? How do I do that?
Then you got to go back to the command line. You can use RIDI.
RIDI.
You can download individual files directly from the model's GitHub repo.
Okay, good old reliable reget. But what about these massive models? Some of these files are gigabytes. Downloading them can take forever.
There's a special utility for that. It's called Hugging Face Model Downloader. It's written in Go, so it's very fast.
Oh, nice.
Very efficient.
Okay, so what makes this downloader so special?
Well, it uses multi-threaded downloading. It breaks the files into chunks, and it downloads them all at the same time.
Oh, okay.
So that can really speed things up if you've got a decent internet connection. And it verifies checksums, too. Nice.
Make sure nothing got corrupted in the download. And it remembers what you've already downloaded. You don't accidentally download the same giant file twice.
So it's like a turbocharged download manager specifically for these models. That's pretty cool.
Yeah.
Now, a lot of us work with Python. Is there a more Pythonic way to do this?
Absolutely. If you use the Transformers library, it actually handles all that downloading and caching for you.
Yeah.
The first time you use a model, Transformers will grab the files, store them locally.
Wow.
You don't have to think about it again.
Okay, cool. So let's talk about actually using these models.
Okay.
I've noticed some repositories have files labeled train, test, validation. What's that all about?
Those are split naming conventions.
Yeah.
Really helpful for organization.
Yeah.
You might not need all those files. It depends what you're doing. If you're just using a model for inference, which is like making predictions, you don't need the train files. Those are for teaching the model new things.
So it's like, yeah, decluttering your code base.
Yeah.
Grab only what you need.
But speaking of training, some of these models are huge, right? Billions of parameters. How can a developer, especially someone without like a server farm, how can we even think about fine-tuning these things?
That's where PFT comes in, parameter efficient fine-tuning. This is where things get really interesting.
Okay.
You can customize these giant models, but you don't have to retrain the whole thing from scratch.
Wait, so I don't need like a whole cluster of GPUs just to tweak a model a little bit?
No.
Tell me more about this.
With PFT, you're only training a small set of parameters, just a fraction of the overall model. One of the most popular techniques is LoRA, low-rank adaptation. It's like adding a small specialized module on top of the existing model. You can fine-tune it for your specific use case without messing with the original model's core.
So I'm basically injecting my own little tweak into this giant pre-trained, beast of a model.
Exactly.
And how much hardware do I actually need for this?
In a lot of cases, you can do it with a decent gaming PC that has a good GPU.
Really?
Yeah.
That's pretty amazing.
And the best part is that the resulting PEFT models, they're just a few megabytes.
Wait, a customized AI model that fits on a USB stick.
Yeah.
What? That opens up so many possibilities.
It does. Suddenly you can have these niche applications, highly specialized models, even personalized AI assistants.
That is so cool. But we got to talk about running these models. Even with PEFT, they can still be pretty memory hungry, right?
Yeah, true. But there are strategies for that. Remember quantization? Well,
yeah,
that can come in handy again. You can quantize a model to make it take up less memory, so it'll run smoother on your hardware.
Okay, so we're compressing it to make it leaner, but doesn't that sacrifice some of the accuracy?
There might be a tiny trade-off.
Okay.
But it's usually very small, especially compared to how much memory you save. It's about finding the right balance.
So I can fine-tune a giant model with PEFT, make it super focused on what I need, and then I can use quantization to shrink it down so that it runs on my hardware.
Exactly.
Am I getting that right?
And all the tools to do this are already out there. They're getting better all the time. Hugging Face, libraries like Transformers. There's even a tool called Accelerate.
Okay, hold on. Accelerate, what is that?
It's this fantastic library for doing distributed training and inference. If you want to really scale things up, you're working with a huge data set, a really demanding model. Accelerate helps you use the power of multiple GPUs, even TPUs.
Oh, wow.
Those are specialized chips designed for AI.
So it's like having a virtual supercomputer.
In a way, yeah. You can push the limits even if you don't have a Google scale server farm.
Wow. So it seems like every step of the way, finding these models, fine-tuning them, running them, there's tools that can help.
There are.
It's a pretty amazing time to be a developer.
It is. The open source nature of Hugging Face and everything around it is fostering so much innovation. We're really just getting started with what's possible.
Okay, so we've got PFT for efficient fine-tuning, quantization to make these models smaller. We've got Accelerate to scale things up. What else is out there? What should developers be looking out for?
One area that's really exciting is RLHF.
What's that stand for?
Reinforcement learning from human feedback.
Oh, I think I've heard about that.
It's a way to train models to be more aligned with human values and preferences.
What does that mean?
So, imagine you could give feedback to a model. You could tell it what you like, what you don't like about what it's doing.
Okay.
With RLHF, it can actually learn from that. It can
Right.
get better over time, generate text that's more helpful, more harmless, more aligned with what you want.
It's like having this personal AI tutor,
Hmm.
and it just learns as you go based on your feedback.
Exactly.
Can you use that with the PFT models?
You can. Absolutely.
Oh, wow.
There are tools and libraries like TRL that combine those two.
Really?
So you can have the efficient fine-tuning and the human-guided learning.
So we've got PFT, quantization, Accelerate, RLHF. It's like a whole cheat sheet for navigating this Hugging Face world.
It is.
But I know there's always more to learn.
Always.
It's a dynamic field.
It is.
You got to keep learning. You got to keep experimenting.
Yeah.
But luckily, the Hugging Face community is really supportive, right?
Pretty supportive.
They've got forums, documentation, lots of examples
Oh, it's a resources.
to help you out along the way.
Mm,
So it's more than just a place to get models.
it is.
It's a whole ecosystem, a community,
Yeah.
a place to learn.
Absolutely.
Okay, so from feeling kind of lost in this model zoo to having this roadmap for finding stuff, downloading stuff, understanding it, customizing it, we've come a long way in this deep dive.
We have. I hope you feel inspired to start building
Yeah.
chatbots, translation apps, maybe a code assistant. Whatever you're working on, there's probably a model on Hugging Face that you can fine-tune and use.
Yeah, but before you dive into building, we touched on something that I think needs a closer look.
Okay.
This PEFT, this parameter-efficient fine-tuning,
Right.
this isn't just a technical trick.
No.
This could really change how we do AI development.
Absolutely.
Imagine fine-tuning one of these huge language models on your own hardware,
Yeah.
like on your gaming PC.
Yeah, exactly.
It's really making AI accessible to everyone.
Democratizing AI
Yeah.
in a way we've never seen before.
So for you, our listener, what does this mean? Independent developers, small businesses, even just hobbyists. They're not locked out of working with this stuff anymore.
No. It's a very exciting time to be a developer.
Yeah.
The only limit is your imagination.
I love it.
Yeah.
Okay, so we've got a toolkit for navigating Hugging Face. We got a glimpse into this power of PEFT. That feels like a solid foundation.
It is, and who knows what amazing applications will come out of this. I'm excited to see.
I am too.
Yeah.
And to our listener out there, we want to hear what you're working on.
Yeah.
Share your projects, share your questions.
Excellent.
Share your insights.
With the Hugging Face community, let's build this future together.
Yes.
Yeah.
Couldn't agree more.
Until next time,
Keep exploring.
keep experimenting, keep building,
Yeah.
and it remembers what you've already downloaded, so you don't have to re-download these huge files and waste your bandwidth.
So it's like a turbocharged download manager
Pretty much. Well,
specifically for these models. I love it. Now, I know that a lot of our listeners work with Python. Is there a more Pythonic way to handle this?
absolutely. If you're using the Transformers library,
Okay.
it actually takes care of all the downloading and caching of the models automatically the first time you use a model in your code.
Okay.
Transformers will just fetch the necessary files, store them locally, and you don't have to think about it ever again.
That is the kind of developer-friendly magic
Mm-hmm.
that I like to see. Okay, so let's talk about actually using these models.
Okay.
I've noticed that some model repositories have files that are labeled as train test and validation.
Mm-hmm.
What's the logic behind that?
Those are split naming conventions, and they're really useful to keep your project organized. You know, you might not need all of the files depending on what you're doing.
Right.
For example, if you're just using a model for inference,
Okay.
making predictions, you don't need the train files.
Hmm.
Those are for teaching the model new things.
So it's like decluttering your code base.
Yeah, exactly.
Only grab the tools that you need for that specific job.
Yeah.
But speaking of training, some of these models are huge. We're talking billions of parameters.
Yeah.
How can developers, especially those without access to, giant server farms,
Yeah.
how can they even think about fine-tuning these models?
That's where PEFT comes in, parameter efficient fine tuning. This is where things get really, really interesting.
Okay.
PEFT lets you customize these massive models for your specific needs
So,
without having to retrain the entire thing from scratch.
wait, so I don't need to spin up a cluster of GPUs just to tweak a model?
Nope.
Tell me more.
So with PEFT, you're only training a small set of parameters.
Yeah.
A tiny fraction of the overall model size, and there are a bunch of different techniques, but one of the most popular ones is LoRA,
Lori.
low rank adaptation. Think of it like adding a small specialized module to the existing model,
Okay.
and this allows you to fine-tune it for your use case
Okay.
without modifying the original model's core.
So I'm essentially injecting my own little custom tweak into
Right.
this pre-trained behemoth.
That's a great way to put it, yeah.
That's incredible. And how much hardware do I need for this kind of fine-tuning?
Well, in many cases, you can do this with just a decent gaming PC.
Really?
With a good GPU, it's pretty remarkable how accessible this has become. And the best part is the resulting PEFT models are often just a few megabytes in size.
Wait, a highly customized AI model that fits on a USB stick
Yeah.
that opens up a world of possibilities.
It does. Suddenly, niche applications, highly specialized models, even personalized AI assistants become much more realistic for developers of all levels.
That's powerful stuff. But let's not forget about running these models even with PFT. They can still be pretty memory hungry, right?
True, but there are strategies for handling that. Remember quantization. Well, that comes in handy again. You can quantize a model to reduce its memory footprint.
Okay.
Make it run more smoothly on your hardware.
Okay, so we're compressing the model to make it leaner, but doesn't that sacrifice accuracy?
There can be a slight trade-off, but it's often negligible.
Okay.
Especially compared to the gains in memory efficiency and inference speed, it's all about finding the right balance for your specific application.
So I can fine-tune a massive model with PEFT, make it laser focused on my task, then use quantization to slim it down so it runs smoothly on my hardware. Am I getting that right?
You got it. And the tools for all this are already out there. They're constantly evolving. Hugging Face, along with libraries like Transformers and tools like Accelerate, make it surprisingly straightforward.
Hold on, you just dropped another new term. Accelerate. What's that all about?
Yeah. Accelerate is a fantastic library for distributed training and inference if you need to scale things up. Maybe you're working with a really massive data set or a particularly demanding model. Accelerate can help you harness the power of multiple GPUs or even TPUs.
CPUs.
Those specialized chips designed for AI workloads.
So it's like having a virtual supercomputer at your disposal.
In a sense, yes. It lets you push the limits of what's possible even if you're not working with a Google-scale server farm.
It seems like every step of the way, from finding models to fine-tuning them and even running them efficiently, there are tools designed to empower developers. It's a pretty amazing time to be working in this field.
Absolutely. The open source nature of Hugging Face and the surrounding ecosystem is fostering an incredible amount of innovation, and we're just scratching the surface of what's possible.
Okay, so we've got PEFT for efficient fine-tuning quantization for slimming down those models, and Accelerate for scaling things up when needed. What else is on the horizon? What should developers be keeping an eye on as they dive into this world?
One area that's particularly exciting is RLHF.
RLHF.
Reinforcement learning from human feedback. It's a technique for training models to be more aligned with human values and preferences.
I've heard whispers about RLHF. What makes it so special?
Imagine providing feedback to a model, telling it what you liked and disliked about its output with RLHF. The model learns from this feedback and gets better over time, generating text that's more helpful, harmless, and aligned with your goals.
It's like having a personal AI tutor that constantly learns and improves based on your feedback. That's pretty cool. But can we use this RLHF with those PEFT models we've been talking about?
Absolutely. There are tools and libraries like TRL that seamlessly integrate RLHF with PEFT, allowing you to combine efficient fine-tuning with human-guided learning.
So we've got PEFT, Quantization Accelerate, and now RLHF. It's like a cheat sheet for navigating the Hugging Face universe.
It is, but we've just skimmed the surface.
Yeah.
It's a dynamic field, so continuous learning and experimentation are essential. Luckily, the Hugging Face community is incredibly supportive with forums, documentation, and a ton of examples to help you along the way.
It sounds like it's more than just a place to grab models. It's a whole ecosystem, a community, a learning platform, a launchpad for innovation.
Exactly. It brings together developers, researchers, and AI enthusiasts to share knowledge, build tools, and push the boundaries of what's possible.
So from feeling a little lost in the model zoo to having a roadmap for finding, downloading, understanding, and even customizing models, we've come a long way in this deep dive.
I hope you're feeling inspired to start building something. Chatbots, translation apps, code assistants, whatever you're working on, there's likely a model on Hugging Face ready to be fine-tuned and put to use.
But before you dive into building, we touched on something that warrants a closer look, PEFT, or Parameter Efficient Fine-Tuning. This isn't just a technical trick. It's a potential game changer for how we approach AI development.
Absolutely. Imagine fine-tuning a massive language model on your own hardware. A gaming PC, for example, is democratizing access to AI in a way we've never seen before.
What does this mean for you? We're a listener. Independent developers, small businesses, even hobbyists, suddenly they're not locked out of working with these powerful models.
Exactly. It's an exciting time to be a developer. The only real limitation is your own imagination.
Okay, so we've got a toolkit for navigating Hugging Face, a glimpse into the power of PEFT, and that feels like a solid foundation.
It is, and who knows what groundbreaking applications will emerge from this new era of AI accessibility. I can't wait to see what the future holds.
Neither can I. And to our listener out there, we're eager to hear what you're working on. Share your projects, your insights, your questions with the Hugging Face community. Let's build this future together.
Couldn't agree more. Until next time, keep exploring, keep experimenting, keep...
Okay, so we've talked about a lot, right? Searching for models, understanding the file formats, those queue numbers, downloading these giant files,
Right.
using the CLI, Regget,
Yeah.
that Hugging Face model downloader for folks who want, the need for speed.
Yeah.
And we talked about Python workflows, the Transformers library, all that good stuff. Those split naming conventions,
Yeah.
Train, test, validation. So you're not grabbing extra files that you don't need.
Exactly.
Okay, but I think it's time to really dig into, the main course here.
Okay, yeah.
PEFT, this parameter efficient fine-tuning. Why is this such a big deal? Especially for, developers like us who maybe don't have unlimited resources.
So you found this amazing pre-trained model on Hugging Face, but it's not exactly what you need, right?
Yeah.
Maybe you want a chatbot, but it needs to be specialized in some way,
Mm-hmm.
or a summarizer, but it's got to have a certain style.
Okay.
In the past, to fine-tune a model, you had to retrain the whole thing.
Yeah.
And that took a ton of computing power, a ton of data.
Mhm.
PFT changes that.
So I'm not retraining like billions of parameters. I can just focus on the ones that matter for my task.
You got it. You're basically adding a small module to the existing model.
Okay.
One technique, LoRaWA,
Wow.
low-rank adaptation. You're injecting these extra parameters that learn how to adapt the model
Okay.
without messing with the original pre-trained weights.
So it's like, yeah, instead of rebuilding the engine, I'm just adding something on.
Yeah, exactly.
How much computing power do I need for this? Can I do this at home?
A lot of times, yes. With PEFT and Lorai, you can fine-tune on, modest hardware.
Really?
Imagine customizing a state-of-the-art model on, like, your gaming PC.
Wow. That's amazing.
That's the power of PEFT. And these PEFT models are super lightweight, too.
Okay.
We're talking megabytes, not gigabytes. You could fit one on a USB stick.
So we've got PET, right, for this efficient fine-tuning.
Right.
We can customize these huge models, make them manageable, but then even with a smaller model, running it can still be a challenge.
Yeah, memory is always the thing. But remember quantization.
Yeah.
Well, that can help here, too. You can quantize your model to use less memory and make it run smoothly.
Okay, so I can quantize my fine-tuned PAF model, make it even leaner. But doesn't that hurt the accuracy?
There can be a small trade-off, but it's usually pretty tiny compared to, how much memory you save, how much faster it runs.
Okay, so I can find a model, fine-tune it with PEFT, and then quantize it to make it run well on my machine. It's like I'm building my own custom AI, exactly what I need.
Exactly. And all the tools for doing this are already out there.
Yeah.
They're constantly getting better. Hugging Face, libraries like Transformers. There's a tool called Accelerate.
Accelerate.
This amazing library for distributed training and inference.
Okay.
If you need to scale up, working with a massive data set, a demanding model, Accelerate lets you use multiple GPUs, even TPUs, those AI chips.
Right.
It's like having a virtual supercomputer.
So I could do the really tough stuff even if I don't have a Google server farm.
Right.
Okay, so we've got PEFT, quantization, Accelerate. This is great. What else is out there? What should developers be paying attention to?
RLHF is a really exciting area.
Well, yeah.
Reinforcement learning from human feedback. It's about training models to be more aligned with human values.
Okay, yeah. I've heard of this. What makes it so special?
Imagine giving feedback to a model, telling it what you like, what you don't like.
With RLHF, it learns from that.
Wow.
It gets better over time, generates better text, more aligned with what you want.
It's like having a personal AI coach.
Yeah, pretty much.
Can you use that with the PEFT models?
You can, absolutely.
Yeah.
There are tools, TRL, for example, that combine the two.
Wow. So efficient fine-tuning and human-guided learning together.
Exactly.
So they've got PFT, quantization, Accelerate, RLHF. It's like a roadmap for Hugging Face.
It's a starting point, but yeah.
But there's always more, right?
Always more to learn. It's a fast-moving field.
Yeah.
Keep learning, keep experimenting.
Luckily, the Hugging Face community is there to help.
Yeah, they're very supportive. Lots of forums, docs, examples.
Yeah, it's more than just a place to find models, isn't it?
It is.
It's a whole ecosystem, a community.
Absolutely.
Yeah, okay, so from feeling lost to having a roadmap, a toolkit, and a community. We've come a long way on this deep dive.
We have.
What more could you ask for?
Just get out there and build something.
Yeah, chatbots, translation apps, whatever it is. There's probably a model on Hugging Face waiting for you.
That's amazing.
It really is.
Well, that about wraps it up for this deep dive.
It does.
I hope our listeners are feeling inspired.
Me too.
And to you out there, keep exploring, experimenting, building. We want to hear what you're working on.
Yeah, share it with the Hugging Face community.
Share your projects, your questions, your insights.
Let's build this future together.
Absolutely. Until next time,
Happy coding.
and happy deep diving.